So in the previous video, I gave you an example. So now it's your turn to have a go. Solve this equation here. Find out all the values of x here. And remember that your normal standard sine of x here, sine of x here, you will give you a period of, well, 0 here will give you a period of 360. So your normal standard sine of x graph will give you a period of 360. So this here will be one period for this one here. But because you've got sine of 2x here, then really you've got two periods here. So this here is one period, okay, and then you've got another period here. So you've in effect got two cycles, one here and one here when you have this. So your first job is to find out that your solution here, your first point here, and once you've got it, you can't simply add 360. You see, adding 360 will take you to here, and look, you've just missed out this point here. So once you've got your first solution, you can't simply add 360, because by you doing that, you would jump to here, and then you missed out this point, and if you jump another 360, you're going to miss out another point. Well, you can't simply add 360. So you've got to find a way of expressing all these solutions here. Okay, even in the negative realm here. Well, anyway, press pause and have a go. Okay, so first step to solve this here, imagine this as being in a bubble here. So you would inverse sine to both sides. So here you've got bubble equals inverse sine of 0.4. And then jump to your calculator. So bubble here equals, jump to your calculator, 0.4, and then inverse sine equals this. Oh, hang on, let me start again. 0.4, and then inverse sine here. That will give you 23, round off to 23.6. Okay, 23.6. So remember, what was in the bubble was 2x. So you can imagine this as being 2x equals 23.6. So x, well, divide both sides by 2. So x equals this number divided by 2. So divide by 2 equals this. Round it off to 11.8. 11.8. So our first solution, well, it's going to be around here. So this value here is 11.8. Okay, now we can't simply add 360. By adding 360, it would take us to here, which is not right. You see, you should add the period here. Well, the period in this case is 180. This is one period here. You see, by you adding 180, that will take you from here to here, which makes sense. And then add another 180, that will take you to here. Add another 180, that will take you to here. Okay, so once you've got your first solution, you can actually take away 180. That will take you somewhere back there. Okay, so hang on. So this is 11. Hang on. Let me clear this up. Our first value is 11.8. Okay, so our first value here is 11.8. 11.8. So it will be. So you can write x equals 11.8 plus multiples of 180. So in effect, it's getting your normal period, which is 360 here, divided by 2. So that will give you the period of, well, develop your own way of doing it. I'm just going to do 360 divided by 2. So it will be a multiple of 180. So it would be 11.8 plus 180. Let's say n here, okay. And don't forget, we've got to take care of this as well. So wait there. This is one period here, 180 here. Okay. So somehow we've got to develop a method of obtaining this solution here. Well, if this is 180 here, this must be. I'm going to chop it up here and just look at and just look at it. Look at this. Hang on. I'm just going to look at this here because that is symmetrical along this line here. You see, hang on. You see, from here to here is 11.8. Okay, so from here to here is also 11.8. So all you have to do is get 90. So all you have to do is get this thing here, 90. Take away this bit here, which will give you, well, if you take away, it will give you this point here. So basically, this will be whether our first solution was 11.8 plus 180 n, and so we're going to get 100. So we're going to get 90. Take away 90. Take away this gap here, which is 11.8. Okay, so calculator. Let me put this into my memory. Here, cancel. So it will be 90. Take away this here equals this 78.2. So this point here is 78.2. 78.2. Okay, so don't forget our first set of solutions will be this and 7.8.2 plus multiples of 180 n, and then we have to state that for all n. Remember, this is a symbol for all n belonging to a set of integers. Okay, so this here would be our final solution. Okay.